Hello 108 students, Mr. McHugh here with you, back on section 4.1, and we are going to tackle page 3 in this video, and we are going to work with objective number 4, which talks about our second technique, which is called the elimination technique. Okay, now we did substitution last video, so now elimination. The idea here is we are going to eliminate one of the variables between the two linear equations, and once you've done that, and you will solve for the other variable, and then we're going to use steps 4, 5, and 6, like I mentioned before, are substitution, the second round of substitution. Okay, sorry, so here we go. So here's the idea. Number one, write both equations in standard form. AX standard form, AX plus BY equals C. What is it? X term plus the Y term equals the constant. The reason you want it in this form is so you can line up like columns of terms and add or subtract to eliminate one of the variables. Okay, the idea here is you get to choose which variable you want to eliminate. Now you've got to have your strategy and you got to keep track of it, and I'll try to show you some easy techniques here to help you with that. You want to pick the easiest one. You want to look at the ones where you've got the opposite coefficients is my recommendation. And I'm going to do an example here in green that's going to illustrate that. Okay, then you're going to have to realize that you're allowed to multiply an equation by any value that you want, as long as you do it across the board, across both sides, left side, right side. We're going to take advantage of that technique. Okay, that's going to help setups for the elimination of a variable. Once you've eliminated a variable and solved for the other one, you've done steps 1, 2, 3. You have either x equals a number or y equals a number. Then steps 4, 5, and 6 are the same as before. You do the second round of substitutions. Okay, so this might take a little while to get comfortable with this, but make a recommendation is number 1, you work vertical. It's absolutely crucial that you do that. And number 2, you number and the original equations and keep track of where you're at. Okay, I can't overemphasize that enough, so you keep your sanity. Okay, so if you go to page 213 of your book, example number 4, I'm going to work it, but instead of doing substitution, I'm going to do the elimination method. So we are going to do elimination. Okay, I picked this example because it's a little easier to see when I look at the variables. Here's the two equations. Look at the columns. Look at the x column. Look at the y column. Notice the y column, that the second equation, here's number 1, here's number 2, it has a negative 1y, and I'm thinking with a negative sign and a positive sign, this y column is easier to eliminate. Okay, so that's my strategy. Now you're like, well, how do I eliminate them? Now the deal is this: you need to get the coefficients of the y's to be a positive and a negative, so that when you add the columns they eliminate and add up to 0y. That's your goal. Now to do that, and this one's pretty easy to look at, I'm going to leave the first equation alone exactly like it is, and that's what I did right here. I left it alone. I took the second equation. This is where you got to use a little mental process and thinking ahead. What do I need to multiply on the y term over here to get a negative 2? And what I need to get is a positive 2, because a positive 2 times a negative produces a negative 2. Okay, so what I did in blue here was I took the entire second equation. I'm going to multiply it by a 2. So here we go. So down over here, I took 2 times 4 and wrote 8x. Okay, 2 times negative 1y produces negative 2. 2 times negative 1 is negative 2. So you got to watch the details of the plus and minus signs and the arithmetic of multiplying correctly. Okay, now what I did here, now this was supposed to be, that green line, I was going to redo it again, is supposed to be a straight line. You now are going to add the columns. Why am I adding them? Because what's 2 plus negative 2? 0y. Thus you've eliminated the y variable. 8 plus 3 is 11x. 13 plus a negative 2 is 11. Okay, now this is the big step right here. This is the elimination. You've rigged it up by multiplying the second equation by a positive 2, so you got that negative 2y, added up the columns, the y disappeared, you're left with x, solve for x, divide by 11 on both sides, and of course you get x equals 1. Okay, that is the elimination technique. Now from here on in, steps 4, 5, and 6 we've done before. Okay, so don't let the number of steps confuse you as to what you're going to do. Steps 4, 5, and 6 are the same. Okay, you have one of the variables. Now somebody might say, hey, I want to eliminate the x variable first. You're more than welcome to do that. In that case, I would multiply this by like 3 and 4 is what? 12, so maybe multiply this by a -4, this by a +3, add them up so the x variable is eliminated. I'll illustrate that over here in the next example. Okay, let's get back to this problem here. You've got x equals 1. Go back, look at the second equation. It is 4x minus y equals -1. I rewrote the original equation. Take the time to do that. Now substitute. X has a value of 1. You found that? Substitute it in. Okay, there's my next step. Okay, I didn't combine them. I kept them as 1. You're working vertically. You're making neat and aggregates. If you make mistakes, if you can't go back and find them, you're going to go crazy. So be neat. Okay, 4 times 1 is 4. Minus y equals -1. Isolate the negative y term by -4 on both sides. I get negative y equals -5. Now, multiply or divide by -1 or switch the signs. Y equals 5. Okay, now there you go. And here's your solution. You found x was 1. You dropped it down. You found y equals 5. You dropped it into the ordered pair. Now, I don't have time for this, but if you're on a quiz or on a test and you found this answer, how could you verify this? That this is the right answer. Take x equals 1, y equals 5, substitute them back into the equations and see if they're true. I would say if you get one of them to work, then you're in pretty good shape. You theoretically are supposed to do both of them, but that might be a tad overkill. Okay, so with that said, that is a way to undergrasp the concept. The book really sometimes makes things harder. They go straight to this, like example 7 here in my class notes. And I happen to label the problems A and B, which is fine. 1 or 2, A or B, it doesn't matter. So here we go. 5x minus 2y equals 4. 2x plus 3y equals 13. Now remember, if you had graph paper, if you want to take time to graph these, you found the intersection, you'd get a close approximation. This technique of elimination will give you accurate, precise answers. Okay, now again, I'm only picking on the y term. You don't have to eliminate the y. You could have done the x, but what I liked to eliminate the y was to realize I got a negative and a positive. I like to look for that because that makes it easy. Now 2 and 3, I need to come up with a common coefficient between the two of them. 2 times 3 is 6. So my goal is to get, now I'm going to cheat and show you here, a -6 and a positive 6y, because when I add this column up, I will get 0. That's your goal of elimination. Now how can you achieve that? I go back, I rewrote the problems, problem A, problem B, look at the brackets. I looked at the first equation and said if I multiplied -2 by 3, I would get a -6. So everything has to be multiplied by 3. That's what I'm trying to illustrate there. Do this strategy equation. Make sure you understand what you're going after. I looked at the +3 and said 3y, and if I multiplied it by a +2, that would give me that +6. And when I add the columns up, the negative and the positive add up. So therefore, that's my strategy step. Now execute. This is a big fancy distributive property where you're multiplying both sides or the entire equation by 3. So here we go. 3 times 5 is what? 15. 3 times -2y, 6y. 3 times 4 is 12. Okay. Keep rolling. Take equation B. Multiply it by what? 2. 2 times 2x produces 4. 2 times 3y produces 6y. 3 times 13 is 26. Why did you do all this? To eliminate the y column. I think I've set that up. Here's the beauty. Add up the columns. Now, what I like to do in class here in Board is I put this big plus sign, and a lot of times I put a parentheses around it. That's to tell me I am adding the columns up vertically. 15 plus 4, 19x. There's the big fat 0 we've been working for. 12 plus 26 is 38. Now, 0 add anything, never change the value. Divide by 19 on both sides. Lo and behold, x equals 2. Okay, that's probably as tough as they get as far as elimination. Once you have the value for x, you guys should know the drill now. Steps 4 and 5 and 6. Take a value, x equals 2. I chose equation B. You could have chosen A. Okay, substitute 2 in for x. So I substitute it in. 2 times 2 is 4. Plus 3y equals 13. Now solve for y. Minus 4 on both sides. You get 3y equals 9. Watch your signs. Okay, this is where students will make a mistake. They'll say 13 and 4 and they'll write 17 and then they're going down the wrong path. Okay, divide both sides by 3. Your closing move, y equals 3. Solution, the 2 was the value you found for x. Y you found to be 3. Put the parentheses. Make sure you write it as an ordered pair as the solution. 2, 3. Okay, hey, that's going to do it for page 3 here. I will see you. We got one more to do for page, for section 4.1. Okay, goodbye.